Hello.
Hi.
Back just in time to do recursion. Thank you, thank you, thank you. And you know what? Since you weren't here to supervise me, real fast, who are we? What are we doing? Hi, I'm Jess. This is Ramon. We teach a free programming boot camp, and we're doing JavaScript right now, or on the free code camp curricula. It's the Bad Website Club. If you go to badwebsite.club, you'll find all the information, and we're going to start. I was
Hi.
so mean to our learners that I actually we didn't get to cover what a call stack was.
No problem at all. You are wonderful, Jess. Today we will start at step 51 to start talking about call stacks and recursion. I'm very excited about this. Just to give you some context. In this script, we've got 3 functions, and I'm going to go through them backwards.
Okay.
First, there's C, the function C that returns the string awesome.
Okay.
Then there's the function B that returns the string is plus the return value of C. Then there's the function A that returns the string free code camp plus the return value of B. So what happens? When we call A then calls B, which then calls C. This is called a call stack.
And
At
it
this
sounds
point,
very literal, like it is a stack of it's a stack of commands that like, hey, go get the next person. Hey, go get the next person. So it's really like passing a fruit salad down at a party. Like, hey, get what you need and then pass it along and get the other person to do what they need.
exactly. So when we're at this stage of the calls, the stack is that we are inside C, which is below B in the stack, which is below A in the stack. So A is at, hold on, I want to see if they agree with me. Okay, no, they don't. A is at the bottom or the beginning of the stack. That makes more sense. Sorry. B is in the middle of the stack because it gets placed on top. And then C is on the very top. But
Okay.
hey, why are we doing this in such abstract terms? How about we go into Python tutor?
And we've learners, go ahead and say hello. We've got a student teacher, a student instructor. I won't say who you are. It's a secret. Shadowing with us to check this out. So, hey, do you teach? Um, and just for context, for our new assistant instructor, Ramon knew about this tool this whole time. I've known Ramon for years. And finally, when he's teaching for the learners, it's like, oh, do you know what? It's probably, we're going to use Python tutor a lot. It's really important. And he is for real seen me struggle for ages and be like, oh, wow, sorry, there's no tool for that.
I'm sorry, Jess.
You should be.
I am.
So you're sorry that you like the learners more than me. Mm.
Never. So here's Python tutor. We've got the same functions and we've got console log the return value of A. And I really want to go through this. We're defining the function A, then we're defining the function B, and then we're defining the function C. There's A, there's B, and there's C. So we go
Okay.
to console log A. So now we're here. We're calling A, which returns free code camp plus the return value of B. Once we do that, we go into B, which returns is a string plus the return value of C. Now we're in C, which returns awesome. So now we're at the scope of C. We're at the top of the stack. We're returning the string awesome. Cool, done. Now at B, we're returning is and the return value of C. So it's returning is awesome. One more step up. The return value is free code camp. And then this return value, which we know from now, is awesome. So we console log free code camp is awesome.
Okay. And this, I think that is this going to be one of these things that we just get used to in time? Because for me, the idea that JavaScript reads stuff top to bottom, but that stacks are conceptually built bottom to top, is a little weird to me. But it'll just be less weird with the passage of time.
Correct.
Okay. All right, we get a little pat pat. Can't hurt us. Okay, because recursion's coming right up. It's right next door.
Then the function b. Oh, and see, we're getting a visual illustration here. So b returns is plus the return value of c. So we're going to update this. Got it. Plus, because that's the return value of of c, sorry. Cool.
Okay,
And we're going
so
to do the
hang on.
same. Sorry,
Okay.
should I go back?
Okay, no, I'm cool. I think I'm cool. Yeah.
So now b has been executed, and we can put its value into here. So is awesome.
So this is really us sort of manually mimicking what the program's doing. It's not because we're building the program out here. It's because we want to sort of really cement in, hey, this is what the program is doing for us when it's making these calls.
Correct.
Okay.
So now we'll move on. Cool.
Hey. Bootcamp is free. Free Code Camp in the name free, but it is a registered nonprofit. If you've got like tons of spare cash right now, because who doesn't in 2024? It is a really nice thing to donate to help them build more materials. If you don't have the cash, don't you go spending money you don't have.
Yep, we can come back and ask me later.
All
So
right.
we will pop A off the top of the call stack. I hope this is what it means. It does. Pat.
Okay.
Now,
So the
while this
call
works,
stack is kind of teaching us about recursion. And just to recap, I don't have my like emotional support hoodie in. This feels like a rookie move. A recursive function is a function that calls itself
yes,
as it does things.
correct.
Okay.
Cool.
Cool. So just remove all the code. Fine. Great. Fantastic. Okay. It can't hurt us. We're just going to try. I'm not even going to wince. I'm going to wince in my heart. We're going to create a new function called countdown. Okay. So const countdown. And then in the smooth baby's number, our arrow function's empty. Okay. We're earning these pat pats because I know recursion's just around the corner. This is fine. Little pat pat. We got a pat on the back. So console log number. Still okay. Still not so scary. Okay.
Everything's okay.
So a recursive function calls itself over and over. And this is something that I'm really good at. So I'm not good at recursive functions, but I am good at infinite loops.
Yeah.
So
So yeah.
infinite loop, please.
No, go ahead.
An infinite loop is exactly what it sounds like. It's a loop of activity you're doing or an actual for or while loop. But it's set in such a way that says go forever. So if you said, I'm gonna make a loop that says, while Jess is still salty that she didn't know about Python tutor, do this thing, it would be an infinite loop. It would never stop.
Correct. And we've seen this before. A loop needs a condition to stop.
Yeah.
For example, a while loop checks a condition, and if that condition is false, then the loop stops. A for loop does the same thing. It has a condition that we check until it stops. But a function that calls itself has no reason to stop calling itself unless we do a check at the beginning of that function for that condition. And this is called, in recursion, a base case. Now, one magical part of return is that it stops the function right there.
Okay, so return doesn't just return. It's also like an enter key on our keyboard to say, "Hey, stop doing what you were doing. Do a different thing."
Correct. So when I call this function, right, which remember all it does so far is just console log the number. Now, we're going to check in that function. Hey, if the number is 0, just stop right there. Even if I were to do like console log hello world, actually, why take my word for it? What's it called again? What's the name of the function? Countdown, right? Yeah, it's
Countdown.
count down 0. Check it out.
I think it's not going to run at all.
No, it does
Oh,
because it
it
prints
does.
out the
It
number.
prints out 0, but then hits its base case.
Exactly. It stops right there. We say like, hold on, if you're 0, get out, get out, get out.
Cool.
If I
I
count
thought it
down
would
with
just say
1,
no.
check it out. It console logs a 1. Then it checks, hey, is number 0? Oh, no, it's not. So we don't
And
return.
then,
We just, yeah.
okay, cool. And this doesn't actually count down because we haven't written that additional logic in yet. So even though the name of the function tells us we should expect to do something that says countdown, we're not there yet. Everything's fine.
Everything is fine. Let's
Is
go ahead and
is
remove that.
everything-
Console
yeah.
log.
Wind up.
Pat,
Yeah,
pat.
little pat pat. Nothing's dangerous. Lisa, this is
Lisa.
such a good question.
So the return x out of the entire function, not just the if statement. Correct. Like the entire function. You're absolutely right. Recursive functions also have a recursive case, which is where the function calls itself. So we can do this and make this into an if else statement. And we're not going to do anything else in this else statement yet. This is where we're going to write our recursive call. So
Recursive
we'll
code.
pat emphasis on curse.
Suspicious pat pat. Suspicious.
So, and here's a good rule of thumb for writing a recursive function. You need to know what's the base case. In this case, in this function, we're checking that number is 0. What's the least amount of work you would need to get closer to that base case? If we're counting down, we want to count down to the next number down, right? So what we can do is we can call count down with whatever the number is as a parameter, as an argument, minus 1.
Cool. I'm literally just going to say the same thing you've said while you're setting up a console log. So when we're writing a recursive function, how do I get out of here? How do
Yep.
I escape this? Like what's my base case? And how do I get there as efficiently as possible?
Correct.
So
So, sorry.
yeah. Stephen's saying least. So least isn't super useful here either. I don't like when I said it. We're looking for the most direct route to stop to get to our to get to our base case.
Yeah, I wouldn't get too hung up on the word least here, my opinion, because what we need to do is we need to change. Like the next recursive call needs to do something differently. In the case of a countdown, we know intuitively we're going to count down by one number. So we go from, and we can try it out. See, here we've got 0. If I count down from 1, it's going to print out 1 and 0. If I do it with 10, it's going to go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. But you know what I'm going to do, right? Because you don't have to take my word for it.
Are you going to go do it in Python Tutor?
You bet.
Hmm.
So const count down equals function with number in it. Put in our base case in our recursive thing. And we're going to call number with parameter 5. Now, watch what happens. So, did I do this right? I think I did. Number's not defined. I keep making this mistake.
Oh yeah. That happens.
It's kind of like a loop in this case. So we'll start at 5, right? We've got our function. So we're currently calling countdown with the argument 5.
Yeah.
Is 5 equals to 0? No. So now we call countdown with 5 minus 1, which is 4.
Okay.
This is our call stack right now. We're inside countdown with 5. Sorry, let me try that again. We're inside number. One more time. We're inside call.
I got you. Let me do it.
You got it.
So we're inside the countdown function, and we started with 4. And while a call stack, we kept stacking more and more stuff on the top. What we've done here is we said, hey, I've got 5. We came through this function and said, well, the number's not 0. come on down and say, oh, go ahead and run the function I'm inside again with -1. And then I come back up to this if and say, okay, we've gone from 5 to 4. I'm going to come back and run through this if again because I'm calling this function again. I've got to go through the whole process again. Is 4 equal to 0? Well, it's not. Okay, the else here. No.
Yep.
Okay, cool,
So
cool. You looked
we're
very
gonna
serious, and I was like, cool. I don't know what a recursive function is, so
you're good. So now we're gonna call countdown with whatever number is, which you might think is 5, but remember we're at the top of the stack and number is currently 4. We're gonna call countdown with 4 minus 1, which is 3. So at the
okay.
top of the stack now, I know it's below, but this is the call stack. So at the bottom there's 5, in the middle there's 4, in the top there's 3. Same check. 3 is not 0. 3 minus 1 is 2. Call countdown with 2. Now this is the top of the call stack. Still not 0. Call it with 1. Still not 0.
-1 from 1 is 0.
So
So
now we're calling countdown with 0. So what happens now?
we're going to hit that return, aren't we? It's going to say, look, here's your base case. You
Yep.
said I should be looking out for if the number was 3 equals to 0.
Yep.
And we hit that. So I'm just
Yep.
going to return. I'm like, I don't want to do any more of this recursion. We're good.
Yep. So cool. We've hit our base case, which means we return. So countdown with parameter 0 is done calling. Return value undefined because we didn't give a return value. Totally fine. Now we're done calling countdown with 1 minus 1, which is 0, which means we're also done calling countdown with 1. So we're out of the function, which means we're also done calling countdown with 2. So we get out of the function, which means we're also done calling countdown with 3. So we get out of the function, which means we also done calling countdown with 4, which means we get out of the function, which means we're done calling countdown
Countdown
with
5.
5.
Cool.
Done.
I obviously conceptually reject recursion as a concept in any shape, manner, or form. Like programming was a mistake, computers were a mistake. Recursion is conceptually scary. This seems less scary than I was hyped for. Like you told us to be concerned, and this isn't hurting me so far. Can we go to the next step and see if it'll hurt us?
Actually, we're gonna first try it out. That makes more sense. So there we go. 3, 2, 1, 0.
Oh, can we do something I think will break?
What's that?
What does -3 do?
Oh.
Oh, we're gonna. Ooh. Oh
Oh,
yes.
y'all are gonna love this. So check it out. 3 minus 4 minus 5. Whoa, 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 whoa,
And this
whoa.
does give us the infinite loop because we have it. um, luckily, a lot of like browsers and like free code camps got us where they're just like, I bet $1 y'all did not want to call this 100 times. Like, stop it, stop it. So we've got our like stop it test. Eh, Perfect. Lisa's like, this is an infinite loop because the base case condition was not set up to deal with -0. Eric's like, look, y'all, that's not going to reach 0. And that's the problem. And
Yep.
we have taken a very indirect way to get to our base case because there's no way for us to get there from -0, -0, or
Correct.
-1, -1.
Cool. Let's keep going. To really see the call stack in action, we just need to modify the function slightly. We're gonna name count. We're gonna rename it to count down and up. And we'll need to we need to update it here.
I'd copy and paste, but you can do you.
My bad.
No, oh, yes, we're all terribly offended. This is the worst thing that ever happened.
Okay, we're gonna, in our base case, we're gonna say console log reached base case.
And this is exactly like the hello world you showed us. This is just like, hey, I want to see if we get there.
Then log number to the console after you. Okay, console log number -1.
I like this because they're
No.
just like, hey, we're gonna show you what Python Tutor does, and we're gonna bop through this because we know.
Yeah. Now we should see this countdown from 3 to 0, followed by reach base case, and the count is 1 to 3. This is because after the ooh, okay.
What?
Let's take a look at that. So, oh, do we want to Python tutor this? Nah, we don't. We know how recursion works. So
Do
first
we?
we console log 3. We check if 3 is 0. It's not. So then we call count down and up with 2. We're not here yet. Maybe we do. Maybe I want to actually.
Yeah.
Let's do this.
I
Sorry,
mean,
friend.
like recursion's going to be the harder thing. And like the learners are so independent. They can definitely do all these lesson steps on their own. I don't mean to tell y'all what I want to do with your time, but like I'd much rather spend time talking about the underlying concepts for this.
Absolutely. So we'll console log number. That's 3. Now we're going to count down and up with 2. Notice we haven't console logged here yet because we're not done calling count down and up with 2. You'll see what I mean in just a second. So now we'll console log 2. Now we'll count down and up with 1. Still not here in the context of count down and up with 2. Now we're going to console log 1. And we're going to count down and up with 0. Still not here. So we'll check. Hey, number is 0. So let's console log reach the base case. Return. Now watch what happens. We're done with countdown and up 0. So we go back to the call stack of countdown and up with 1. Now we can console log 1. See? Now that we're done with countdown and up 1, we're back in the scope. We're back in the stack of countdown and up with 2. We'll finish that function. Console log number is 2. Now we're done with countdown and up 2. Pop 1 back up. Pop, by the way. Does that sound familiar? Push and pop. We're pushing stuff onto the call stack and we're popping stuff.
Oh, so we're thinking about the same kind of. Where were you when? So it's not just that you were holding back on Python tutor for me, but like where were you when all my friends were doing computer science degrees?
Ah. Right. So now we'll console. So we're done with countdown and up with 2. So we can console log in the stack of 3. Console log that 3. Cool.
Okay, I'm concept.
Oh,
Because
you
you're
should.
not.
Oh, should we delete it?
Uh.
Oh, it's time to do some actual decimal to binary conversion. Cool.
Oh, so it's like no, just go ahead and delete the whole thing. Oh, Stephen's giving us a way to frame this, and I'm going to try this. So, and Stephen's asking, hey, could we think about this as everything above the recursive call executes repeatedly until the base case, and then everything after the recursive call executes, but in reverse?
I'm gonna be honest, Steven, I don't quite understand that. I'm so sorry.
Yeah, I think that this might be a
There's
yeah. We'll come back to this and try and reason
I've
through it. If you could
bookmarked
just
it.
describe that in a bit more, because it was just maybe
Ye-
like this sounds like something that makes sense, but I do not have the the spatial imagination to make it happen.
Um,
And Jane, I see a
Jane,
really good question. I'll save this one too. Or not.
Jane, I recommend also because you're saying you don't think you'll ever understand this down and up one. Why does console logging reach base case trigger this action? I would plug it into Python Tutor again and follow the actions. Because it's not console logging reach base case. The fact that we reach that base case means that we're done. We go into return and then we pop out of the call stack. We'll walk through this again during Q&A, but like we'll get there.
Usually I say it's just JavaScript. It can't hurt us. This is just recursion. It can only hurt us a little.
So, ooh, did we do this yesterday? The actual writing of decimal to binary?
Many people did for their homework.
Fantastic. Let's walk through it real quick.
Yeah.
To convert from decimal to binary, we're given a number. And then if that
If it's
number
0,
is if the number that we put in decimal is 0, we return the binary as 0. Otherwise, while input is bigger than 0, we will convert the binary of input. Modulo. Did we do modulo?
we did not talk about modulos. We should talk about modulos because modulos aren't cursed, but they're like
They're fun.
They're a programming only kind of vibe, right? I love you just, like, rolled up your sleeves.
I
Between
love
you and
modulo.
like, Stuart went on a whole, like, "Let's talk about why binary is exciting," um, little journey,
Love it.
and I love you doing the exact same thing, like, "Yeah, let's get some modulo."
Cool. Let's talk about division for a minute. Before we do any of this decimal stuff, let's talk about modulo for a sec. Let's talk about division, pardon me. 5 divided by 3 is 1.666 recurring. Cool. We also know that 5 divided by 3 is equals to 2, no, pardon me, is equals to 1 remainder 2. So what if we wanted to know, hey, what is the remainder? How much is left over if you divide 5 by 3? That's 2.
So modulo is just like, if you divide this by that, what's left on the table?
Correct. Because if it can't divide to a whole number, an integer, what's left over? For example, what's the remainder of 5 divided by 6? Well, 5 doesn't divide evenly into 6, so the remainder is 5.
Okay, so you get the original number with a modulo when it's just like, "No,
5 modulo 5.
nothing."
Yeah. So 5 divided by 5 divides into 5 evenly, so there's no remainder. Same goes for 10. No, pardon me, if you divide 10 by 5 is what I meant, then it leaves a remainder of 0. Same goes for 15. Because 15 divides into 5 evenly. 16, on the other hand, leaves a remainder of 1. Now, we did
Okay.
talk about binary a little bit yesterday.
We did.
So,
Sorry, did
no,
you
no,
see me be like, "Mm."
you're good. So,
Oh.
we're checking
Oh.
here. Hey, remember this input is a number that we input into our field. What is that number? What is the remainder if you divide that number by 2? Right?
Okay. I'm with
If it's
you.
an odd number, the remainder is 1. If it's an even number, then the remainder is 0. Because we're turning in you know
Yeah,
what?
yeah.
Do I want to? Oh,
Are you going to use a very helpful tool?
you bet. We're going to leave out this part and instead console log binary.
And I should add that Ramon lives very far from me, so he's safe. I'm not gonna actually show up at his house and shake him yet.
Whew. Okay, cool. So, cool. Let's convert 5 into binary. So, we have a string called binary. It's an empty string. Cool. Is the input 0? Is the number 5 0? Well, it's not, so we keep going. So while input is bigger than 0, we check, hey, take the string right now as it is empty and set it to be whatever the remainder is of dividing that input, which is 5, by 2, add that to the beginning. So that remainder is 1. In the meantime, we're going to round down whatever it is that you divide 5 by 2. 5 divided by 2, rounded down is 2. So check it out. Input is now going to be 2. Notice we prepend the remainder if you divide 2 by 2, which is 0.
Yeah.
So
Yeah.
what is 2 divided by 2 is 1. Now we do it again. What is the remainder if you divide 1 by 2? It's 1. So we put that at the beginning of the string, and we set input to be 1 divided by 2. Round it down, which is 0. Hey, input is no longer bigger than 0. Let's get out and console log our binary number.
Okay. I don't love it, but do you know what? And I don't know if anybody else gets this as well. Like, one of do you know about the fear with learning?
No?
Oh, so I was bad at math or maths, your choice. growing up, and then I eventually developed what me and many other, actually some educators as well, will talk about as the fear of maths, where and people get it with programming, people get it with language learning, where you see something from a area that's really challenging for you, and you just kind of shut down a little bit, where you're like, ha ha ha, let's convert it to binary. I was like, no. But this
I
was a
feel that.
very warm, and the whole point of the Bad Website Club is we want to try and like avoid the fear as much as possible. So this, while mathy, wasn't harmful. Like, it can't hurt us.
No. I
Let's
always say,
delete all of
like,
this. Oh, sorry.
yeah. No, I always say, like, not knowing is a part of learning. So I need to
And
accept that I'm not gonna know something until I know it. Pat pat.
oh, do you know what? You're much more reasonable. Sometimes I just accept that I won't know things and be like, look at that. Good for them.
I mean, it's still part of learning.
So we've taken all that out. We love to delete code. Cool. I remember this. I'm not even going to look at the instructions. We need to go ahead and set our base case, and then we need to think about how to get there. So if the number is 0,
Mhm.
Stuart said we shouldn't say 3 equals because it's not going to make sense in job interviews. It is the strict equality operator. But
Cool,
he
I can
also
do
said
that.
I couldn't say curly babies for curly braces, so we just won't have him back.
Oh, I love Stewart.
Monica points out that fear is the mind killer. I've tried to read Dune so many times. Like I tried to watch the movie as well. I respect that it's very popular right now, but like Duncan, Idaho, please, I can't take it seriously.
I
I
started
know.
the book.
Okay, wait, hang on. We definitely talk about pop culture in the Discord. So
Cool. So there's
if
our
it,
base case. If the number is 0, we return an empty string. This seems familiar. Let's keep going.
this is a lot like what we just deleted.
Pat
Oh
pat.
yeah, definitely. All of our pats count in recursion.
So we'll need an else statement, and we will return the result of calling decimal to binary.
Mm,
We will pass in the input.
so that's input divided by 2.
So that number divided by 2, rounded down.
So that goes in parentheses to oh wait, you've already done the math dot floor.
Yep.
I was just like, go outside that. You'd be like, oh, Jess, I did.
If it were up to me,
It would do the same thing, but it's more human readable.
I mean, it's not the best variable name, but hey,
Look. It can't, yeah.
cool. Will that accept it?
Okay.
Wow, they really don't like variables. Fine.
I mean, tests are hard to write.
Yes, that's very
Also,
fair.
they wrote us this whole beautiful curriculum for the entire world. So if you complain, I'll get you
I'm not going to complain. Never. Pat, pat.
because I'm still going to get you for this Python tutor thing.
Very
Okay.
fair.
So input gets cut in half each time, about half each time decimal to binary is called. But the decimal binary string is calculated by taking the input divided by 2 and concatenating, sticking it on the end, like stapling it to the end. Concatenate, staple to the end. So after our call decimal to binary, say plus, and I'm so sorry. I'm gonna call somebody out for like saying they didn't know something, but it's productive. And Steven said this was kind of hard for me because I forgot that it's not just concatenation with strings, which is a plus, but the plus here is can be both an operator, actual maths plus, or it can be concatenate, like add, like connect these two objects.
Cool. So we're taking that recursive call and then adding to the end of it input modulo 2. Finally, in your check user input function, set the text content of our result
Okay. Result dot text content.
into the string returned by.
And text content is the we got get element by ID for this div in the yellow box. Okay.
Correct.
This seems suspiciously okay.
Let's pat pat.
Surely this next one will come and get us. Okay, so this is okay, I was just like, "Ha ha ha, they make us beautiful materials. We can't ask too many questions, we can't make too many demands." For me,
Yep.
I'm like, "Look, we've got, like, 90 some odd steps here, but here on step 71, it just works." So, like, yeah, yeah. But if we test our converter with 0, it doesn't work. So oh, the base case needs to return the string 0. Oh, when the input is equal to 0. So we found, oh, wait, I'll ask the learners. Learners, have you ever heard of the term edge case? And I don't know if this would really count as an edge case.
This is
So
definitely an edge case.
what do you think edge case might mean if you've never heard of it before? So an edge case is something you test for or a problem with your programming. What do you think an edge case might mean? Because 0 is the only one we had to do this special little stuff for. Other than 0, this just magically works.
Yep. But notice the difference. Now we've got a 0 at the beginning of every binary number we convert. Is this a bad thing? No. Because as we know from decimal numbers, 0, 1
Is 1.
still the same as 1. So it's technically correct.
Oh,
What if
no,
I
but technically correct means we're probably gonna do it in a way that feels much more correct.
this is still 2.
This
This
is
is
what
fine.
Stuart was doing with us, where he was like, "Hey, this is how we kind of count it out."
Yep.
Oh,
Mehmet's got it. Oh, wait. Yes,
yeah,
no,
yeah.
you've got it.
0, 0, 0, 0 is 1. And Monica's got a great one. So all the weirdest scenarios that would break your code. So that's true. An edge case is when there's a bug or a problem, but it's like a really, really hyper specific thing. So if I said, "Oh, hey, my electric toothbrush doesn't work when I try and brush my teeth using orange juice," and I call the electric toothbrush company and they'd be like, "What? What? Just stop doing that." So sometimes edge cases in software are so specific that they don't get fixed because you don't fix if when a program gets to be a certain size, you do not fix every single bug.
Totally.
And I'd say that at least for me, that program is any size. So
Cool.
this mostly works. I would
It
say
does work.
done. And
I
that's
would take
why I don't write software.
so yeah, we've got a leading 0, which is totally fine. If we put in a 1, we get an O1. So what we're going to do is expand our base case. So if our input is 1, we'll instead just return 1. Let's give that a try now.
I
So
bet
yeah,
I can see the future. So because this feels like we could write this in kind of a zippier way.
now we don't have that leading 0 anymore.
Yeah. Which was technically correct, and we love being technically correct, but it wasn't graceful.
Very satisfying. 1, 0, 2, 3. I think should give me a big bunch of 1s.
Come on, come on, come
Cool.
on, come on. Yes.
Pat, pat.
I am very impressed by how little this has hurt so far.
So since we know that the input will be either the numbers 1 or 2 at this point, we can combine our two base cases to adjust return input as a string. For a reliable way to return a value as a string, even falsy values like null or undefined, we can use the string function. So we say, hey, we've got a number here called 5. Can you console log that as a string? Thanks. Can we console log null as a string? Then it'll
Yeah.
turn that into a string.
Okay. So
So what we're going to do is unexpand our base case to say, hey, if the input is 0, hold on, let me get rid of one of these parentheses. Or, where's my or?
the bar.
So if it's equals to 0 or equals to 1, return
String and then input.
Yep.
Yeah. Do it.
That's a 0. That's a 1. That's a 2. Fantastic. Pat, pat. Sorry, Let's keep going.
Yeah. Okay, our decimal to binary function is complete.
Mm-hmm.
Oh, so what we're going to be doing now is building a simple animation. So here, right now, step 74, you have done the thing. Everything's fine. Remember earlier, what yesterday with Stuart, how it had us work through some binary problems that didn't actually lead us to the solution for this, but wanted to sort of ask us to show that we understood binary a little bit, like expand on that for us. And this is going to do a really similar thing. Do we want to? I I'm s- let's just look at some of these steps together and talk about them.
Yep.
Um, I know that I'm always the mean teacher, but I think one of the problems is that often if somebody shows you every single thing, sometimes you can miss out on really valuable understanding. The big thing I'd ask learners to do, even if it feels silly, is as you're doing these, could you talk to yourself out loud or talk to your cat or talk to your rubber duck or talk to your picture of your great grandma? But just say, okay, in this step. So read the instructions and then talk about what's going on. Um, yeah.
Yep. So I might be pretty mean myself and recommend that. How
Is it
about
Python tutor?
I was gonna say, how about instead of continuing to do the lessons, the one other concept that y'all would learn here is timeout setting, and we could look
Let's
into
look at
that.
that. Let's look at timeout settings. I was going to abandon them. I'm a monster.
Let's briefly look at timeout setting because I think that's the only like other concept other than recursion that this will teach us, and we'll leave the rest of y'all for y'all to do. But let's look at timeout for a minute because I think that's pretty important.
Yeah. Thank you.
All good. So, um, we've learned recursion. Fantastic. Let's look at set timeout for a minute. Now, do you know what I'm going to do?
Yeah.
Where's my convert button function? Convert button. Check user input. Yeah. So, const timeout setting equals. We've got a function. So, we're going to use something called set timeout. And what this does is we will manually tell JavaScript, "Hey, can you run this piece of code after a set amount of time that I tell you?" Let
Okay.
me show you.
So it's like setting almost a countdown, but it's like a timer on your watch or a timer on your phone or a timer in your heart to say, "Hey, cool. I need to get up and get my baked potato out of the oven in 15 minutes." But this is, "Hey, don't run this code until the baked potato is done. Let the potato sit a minute."
Yes, exactly. So we're going to have this timeout. Um, bear with me. This E is the event. Again, bear with me. So we're going to have this timeout. And the first parameter of this set timeout function, which is available in JavaScript, set timeout is available to us globally in JavaScript, and it takes two parameters. One is a callback to be called, and then the second one is a time, a delay.
Okay.
This delay is the number of milliseconds or seconds divided by 1,000 or thousandths of a second until this callback should be called. For
So,
example,
please.
sorry, I was just going to say, like, if you want this callback to be called in 5 seconds,
5,000.
5,000.
I was gonna say, if you wanna wait a second, so can we just really, really briefly talk about the amount? So 5 seconds doesn't seem like a long time.
Nope.
On a website, it's such a long time.
Oh, it's such a long time.
So and this is really so when we talk about the things that you put on your website,
Mm-hmm.
5 seconds. So if you say, "Hey, cool, it only takes 3 seconds for my web page to load," there's a ton of research that says hey, you know what? If it takes more than, I think it's a second and a half, 2 seconds, that some people just bail out and a noticeable number of people just bail out because they're like, oh, this website, I wasn't that fussed about it anyway, and it's taking forever to load. So make your websites as performant as possible for flighty people like me, but also those 5 seconds are not equally distributed. If you've got folks accessing your website on spotty connections, you've got folks accessing your website on not the fanciest devices in the world. Like, if you are building for a global audience, you need to be really, really thinking about, do I need a great big picture? Do I need a bunch of JavaScript? What is the least I can get by? Because A, it's faster and cooler, and B, it's fair and right. Mehmet's asking, hey, will this timeout only work once?
Yep,
Um,
that's right.
I was
Extra
gonna
once.
guess. I think yes, because you're saying, I'm setting a timer, then run this code, and it's gonna wait for that timer to be up. Yeah.
Yep.
Mehmet, you
That is
ask stunning questions. Thank you.
love it. So cool. After 5 seconds, we will check user input with E. You might be wondering, why on earth would I want to do that? Because what I'm doing is when I can press the convert button, instead of checking user input right away, instead, I'm going to timeout setting with that click event. I'm going to wait 5 seconds, and then I'm going to run check user input with that event. Now, I'm just going to put my hand up here. I'm going to put in the number 20, and I'm going to click convert, and then we're going to wait 5 seconds. Okay. Tower Defense, I'm bookmarking that because that is a good Tower of Defense. Tower of Brilliance, I'm going to bookmark that because it kind of answers Mehmet's questions. So, cool. We're going to convert the decimal number 20 to binary. So I'm going to click on it. 5, 4, 3, 2, 1. I'm going to feel really silly if it doesn't work. Hey, did you see that? So after 5 seconds, it did the conversion.
And it didn't wait to show us, it waited to run the code.
Correct.
Yeah, and this is great because we see that because the JavaScript we wrote is not a ton of JavaScript. It's not super fancy, it's not super complicated, and it ran like that. We waited 5,000 milliseconds, but the
Sounds like
actual
a lot.
time it took for the code to run didn't seem to add even a whole other second.
So that is a countdown to running that code.
Okay.
In fact, tell you what. Set your timers 5 seconds until, and then when it,
And, like, really, that's a little bit of a lie because it might be, like, 5,001 or 5,003 milliseconds for the timer and the actual running of the code. But, like, while a second is a terrible amount of time to wait for a website, a millisecond doesn't really hurt us too much.
so we're going to do it again. 4, 3, 2, 1, boom.
Wait. Okay, so we got that converting now right before it gave us and it was really we couldn't really tell the difference at all. So timeout is saying, "Hey, wait a certain amount of time before I run this code."
Yeah.
Okay.
Cool.
I might use this for something where I'm saying, oh, do you know what I'd use this for? Do you know what my
No.
inbox uses this for? Is I've got like a undo on my inbox where it's just like, your email sent. Did you mean to be that mean? Do you want to undo it? I'd be like, I do want to undo it. That was a little mean. So that's
Perfect.
probably what's going on under the hood where it's like, cool, we're going to send your email, but we got a little timeout on it. We're going to wait just in case you want to rethink some of them words you're using.
Perfect.
Or for me, do you want to spell that right? You spelled somebody's name wrong. Okay. After recursion, timeout doesn't seem like it can hurt us that bad.
No. Do we want to do
Oh,
something kind of weird?
every moment of every day.
How about after you do that timeout, we do another timeout.
Okay.
So
To do
once those
what?
5 seconds are up, just like let's just mess around with this just for a second. Bear with me.
Okay. Because you were like, "Do you wanna get weird?" I was like, "I don't why? Okay."
So
I said we would never do this in actual user stuff
no,
because if you made me wait 5 seconds and then you made me wait 5 seconds, you better be giving me a cake. Okay, I thought you were like 5 seconds, 5 seconds, I thought you were just gonna leave us in 5 more seconds, like a chain of that lasting forever.
no, I would never do that. This is me with alarm clocks, by the way. Just need another 5.
No, that's so bad for you.
I
Like, I don't
know.
do it.
So now we'll do it. So set your timers 5 seconds. 3, 2, 1. Hold on. I need another 5. 3, 3, 2, 1. Now we convert it.
Okay. Okay, so it is just a timer, and we could put them inside our code and say, "Hey, after this happens in the code, wait a millisecond or 5 seconds or 17 hours."
Wouldn't recommend it, but you can.
Do you know what? Is that how those idle clicker games work, like kitten games? Like Kitten's game?
Oh, most likely.
Yeah.
The one I knew was with,
Was it the paperclip one?
yeah, the paperclip one.
Okay, so I'm gonna go get it because actually
I think this might actually answer Tower of Brilliance's question. What is the difference between set timeout and set interval? Let me try set interval actually.
yeah.
So now what happens? 255. Watch here. So 5, 4, 3, 2, 1. Hold on, I need another 5. So now it's going to run this callback every 5 seconds, infinitely. This is me getting out of bed.
And actually, if it's okay, I'm gonna show off this. So Kitten's game is actually.
So that's the difference between timeout and interval. Timeout does it once, interval does it infinitely. Every X amount of milliseconds. Ah, shall
So
we do some Q&A? Sorry.
yeah, I was actually gonna show Kitten's game just to show what these weights might feel like.
Sure.
Also because their GitHub is available. So here's the code project for this clicker game. And this clicker game is click, click, click. You gather catnip, and then you build a field, and it gathers more catnip, and it'll make you wait before you take more steps. It'll be like, okay, let's wait until this hits. But the thing I like about this is all of the code is here. So you can see how this is made. It's going to be super complicated. The reason I was actually excited to show you all the code is remember when we were talking about do I do function with the function keyword or do I do these arrow functions? I was so excited about this. Um, look at this. Hey, the shared conventions for this project. If you're going to contribute your code, please don't do these arrow functions. I don't love them.
Oh, wow. But see, but I told you, like, some people like them, some people don't.
And the thing is, so this is somebody who's made a video game, very simple video, put all the code online. Other people can contribute, other people can offer changes, other people can take it and make their own versions. But what she's saying is, look, if you're going to contribute code back into the project, just here are the ways I'd like to see you write it.
I love that. Cool. Let's look at some homework.
Oh, let's look at some questions.
Yep, just
And both.
a preview because like we didn't finish everything. We've left a lot of homework, but here's what I recommend, friends. We've covered the most important parts. If you want to go ahead and finish this, remember this is self-paced. We're going super fast through this. Tomorrow we're doing the Roman numeral converter project, and I want to preface a question, if I may.
Mm.
From these examples we've seen here, a question that might have come up is, well, recursion seems like loops. When should I use one over the other? There are cases where you will need recursion. There are cases where you will need loops. they can be used the same way. I would say in those cases where one or the other can be used, go with your gut. There's no wrong answer. Don't overthink it. But if you have a lot of them, you know what I'm going to say. Be consistent.
Cool.
Okay, now we can do questions. Question is, can you think about it being recursion as everything above the recursive call executes repeatedly until the base case and everything after the recursive call executes but in reverse? No, I would say no. I'm sorry, Stephen. Let me.
So that might, yeah, I think, Stephen, you may have like spatially built something in your head that like is a really, really exciting way for you to visualize it. And we just can't come on you with this journey. But we can take a look at this together.
Yeah, I'll tell you what, let's look at, wow. That's not a lot of code. So here's our binary converter. Decimal to binary. Let's go with 5. Let's go with 7. Console. Okay. So we're calling decimal to binary with an input of 7. So first we check our base case. Is 7 equals to 0 or 1? Nope. So we move on to the next one. We're calling, oh, wait a minute. I'm so sorry, friends. I just realized I'm not in free code camp anymore. I have all the powers I want. Ha ha ha. I can do whatever I like. I love this. Oh, I feel so powerful right now.
Okay. I love that.
Let's call this binary representation.
Stephen, I see some good questions from y'all. I'm just, and Eric as well. I'm just grabbing those. Everything's fine.
Cool. All right, let's go again. So 7 is not equals to 0 or 1. Cool, whatever. It's fine. Now we're at const half rounded down, which is going to divide 7 by 2 and round it down. 7 divided by 2 is 3.5, which if we round it down, we get 3. Cool. What is a binary representation of 7? What is the remainder of if you divide 7 by 2? It's 1. Cool. Now, we've got these two numbers. Next, we're going to return the value of calling decimal to binary with half rounded down, which we know to be 3. We're not going to do anything with binary representation yet. We don't care because we're one step further down in the call stack. Now we're doing input is equals to 3. Cool. Is 3 equals to 0, 1? Nope. So 3 divided by 2, rounded down, is 1. 3. What is the remainder of 3 divided by 2? It's 1. So now we're going to call decimal to binary with 1. Not worrying about binary rep yet. So, hey, input is equals to 1, so we'll return 1 as a string. Cool beans. So our return value is 1. Hop back out to this part of the call stack. We're returning 1 plus binary rep, which is 1. So 1, 1. Now we're going to return 1 stack call up, that 1, 1, and the binary representation of 7, which is 1. We're done. Cool. I recommend playing with this a lot. Jane, I hope this helps you also with this sort of like up and down stuff.
Stephen's got a different way to say this. Okay, looking at this, a better way to say it is lines 2 to 7 are going to repeat until the base case is reached, and then 8 and 9 will get involved.
Yeah, that works.
Yeah.
Totally
So
works.
as you were stepping through this, I was like, because before I was like, Stephen, I'm sorry, babe. It's very, very unfamiliar. I am sorry, I can't visualize this. And then as you're stepping through it, I was like, Oh, no, wait, I'm starting to be able to visualize this. Oh, hang on. I can answer this question. So I'm the boss. Eric saying, I want to do web development. Yes, yes, yes. Who does not love a universal publishing platform? Yeah, the web. Which concepts in JavaScript are the most important ones to use in web development? And I'm excited to answer this question because I'm going to answer it without answering it in the most teachery way possible, which are so come on through this course. Yeah, yeah, everything's fine. And then once you're done with this, let's start making a couple of little projects. And then the most important concepts to learn are the concepts that you keep bumping your nose into. So if you say, "Hey, you know what? Stuart yesterday taught us a way to like turn like a shorthand to turn numbers into binary," and I've never seen that in my whole wide life. But if you're doing stuff in JavaScript where you need that a lot, cool. That was the concept you've needed. So keeping a document or keeping Ramon, I know you've got yours on your table as well. Keeping a paper notebook and saying, "Cool, you know what? I keep seeing I
Too
keep
many.
I keep seeing recursion pop up." Although Mehmet is like, y'all are answering this in really fluffy ways. Functions are important, array methods are important. Okay, look, there's real answers to this, but the most important ones are the ones that get you again and again.
Yep. I think for a lot of this, um, I'd love to share a recommendation we got from our teaching assistant, which is an IT journal. I think one of the the most important things to do is to keep it keep track of which parts you learn, keep track of which parts you struggle to learn, and try to explain them. One of the best ways of learning JavaScript I did was to teach this boot camp like 3 years ago. Like seriously. When it comes to web development, data structures are going to be important, as Mehmet said, array methods, understanding complex object systems, being able to track these parts is going to be important. Stuff like map, filter, reduce. Don't worry if you haven't heard of these yet. I'm just pointing them out. Understanding the life cycle of a JavaScript callback. Uh, Promises are going to be a thing soon, and I promise they're not as bad as they sound. Um, there's a bunch of concepts and like web development with JavaScript. Remember that JavaScript, it at the end of the day is going to do two things. One, make your website dynamic because otherwise you just have static HTML and CSS. And number two is transmitting data to and from a server to a backend. So being able to receive that data, which we already learned how that comes in, JSON, and displaying that, interacting with our DOM, those are the two big parts. Now,
I'm going to be super mean. No, now I'm going to be super mean.
yeah,
We're going to hustle through these last couple of questions because I've got a
don't
live
be
stream I
mean.
really want to watch about surveillance technologies.
Just we're out of questions.
Oh, if anybody else wants to come, it's just like it is not part of the class. I'm just interested in it, but I'm going to a live stream to listen about surveillance technology because I'm a big surveillance technology dork.
Cool. Well, thank you all for joining. Tomorrow we'll be back to do the Roman numeral converter,
Oh, I bet it's
and
gonna feel real same. I bet they're gonna get us with some recursion.
they could. We'll see you all tomorrow.
Bye, my loves.